With that, let's end our discussion on release strategies and release plans and focus our attention on promoting builds through the deployment pipeline, which is quite an interesting topic. Okay, before we take a deep dive into promoting an application, we need to talk about first deployment. And you would know that the first deployment is obviously not going to be for release, right? You're not going to take your application and deploy it immediately. You are obviously going to take your application, you're going to deploy it for some kind of testing, right? Only after you've tested your software in the production environment would you actually release it to the general public. So usually that first deployment that you do for testing is the one that you do for showcasing. I hope you remember what showcasing is from software engineering. If you don't remember what it is a bit like what your parents do when when guests come home, right? They take all your trophies and keep it in the front of the house so that they know that so that the guests know what to expect from this house. You are their products and they are showcasing you. Just like that, a company makes products and they showcase it to their clients, right? So that the clients feel impressed with the software. This particular showcase deployment is a bit like pump priming for a centrifugal pump. You know what pump priming is, right? The centrifugal pumps cannot pump air, and so we pump in some fluid to get the air out of the pump, right? Which is basically helping you get your pump ready for the actual pumping. You're going to push water into the pump, get all the air out. Just like that, your deployment pipeline, there could be some bottlenecks, there could be certain issues in the deployment pipeline. When you run a sample when you run a sample build through this deployment pipeline, if there is something wrong with your deployment script, then you can easily find it out before you actually release your software. Right? So let's just try and see how exactly the first release would happen. Right? You will take your source code from the version control, and then you will also take the configurations from the version control. You would go straight and you would build your binaries, you will build the executables, and then you would deploy it into production. You could say production or an environment that is as close to production as possible. We'll elaborate on that a little while later, but we will deploy our software. And once we're done, we can now go outside and have a good smoke. No, that's not what I'm saying. It's not smoke. We will actually go outside and we'll perform. We won't go outside. We'll deploy the software and we'll perform a few smoke tests on the application to ensure that our deployment went really well. And I hope you remember what smoke tests are. Smoke tests are tests that tell you if something is wrong or not. They are not tests that tell you exactly what is wrong, but they can tell you if something is wrong or not. And so we deploy our applications and then we perform smoke tests on those applications, right? I told you that we'll elaborate a little bit on the production environment. When in your first release, you want this test deployment to be into a system that is an exact replica. You want to do it on an exact replica of your production environment. However, this may not be possible at all times. You may not be able to get an exact replica of the production environment in for this particular first deployment. There could be many reasons. Sometimes it could be impractical to have such a setup in your in your office. For example, if the production environment includes 2000 systems, but you don't have the money to have 2000 systems, nor do you have the space to install 2000 systems. So in that case, you cannot have an exact replica. So you would go in for a system that is as close to production as possible, right? If you can't get an exact replica, you go for a production like environment, right? Even when you go for a production like environment, when I say production like, I mean a system that is very close to production, but it is not exactly the same as production. So what are the aspects where you can make compromises on? What are some compromises that you can make, right? There are many things that you can make compromises on, but we will talk about the things that you should never make compromises on, right? The first one is the operating system. Never compromise on the operating system. If your production environment runs Windows, then test it on Windows. Don't use Linux and then try to emulate Windows on top of it, because it will result in performance degradation. Similarly, network architecture should never be and system and network architecture should never be compromised. You should go in for the right architecture, although you can compromise on the number of nodes. Sometimes you are required to have 15,000 nodes, but that may be impractical. Like I said earlier, that may be impractical for you. So you can compromise on the number of nodes, but not on the protocol. Use the right protocol, use the right network architecture, things like that, right? Also the process architecture. Never compromise on the CPU architecture, never compromise on the network, CPU architectures, system architecture, other system architectures, and operating system architecture, right? So what are the things that you can actually make compromises on? Yeah, you can obviously make compromises on certain libraries, right? Certain libraries. Maybe that you've not received the actual license for the library. You've not received the license to use the library, so in that case, maybe you could use some sort of virtualization or some kind of test double to emulate that environment. Also, you can, like I said earlier, if you can emulate the number of nodes. For example, they say that you should have 50,000 nodes. You can't have 50,000 nodes. What do? You can emulate 50,000 nodes using a network emulator. All of that is permitted, right? So that is all about the first deployment. So points to keep in mind are when you're doing that first deployment. The first deployment is obviously the showcase deployment. It's like a pump priming step, and you must always smoke test your deployment. Once the deployment has been done, you must smoke test it to see something is wrong. And as far as the production environment is concerned, ensure that you always keep the system architecture intact. Have a system that is as close to production as possible. And the things that you can, there are certain things that you can virtualize. Virtualize essentially means something like emulating the presence of a hardware or a software, right? So you can virtualize things that you cannot acquire, right? Okay, so that's it about first deployment. We'll do a small review of a concept that you're already familiar with, which is modeling the release process. So whenever you create a model for your deployment pipeline, what you do is you decide upon the various stages that are there. There are three things that you must consider, but first of which is the stages, right? What are the various stages in your release process? What are the various stages that are there in your deployment pipeline? There could be integration testing, there could be acceptance testing, there could be user acceptance testing, there could be a staging, and then finally you can release your software. And you may have noticed that in between these stages, there are certain gates, right? So what are these gates there for? These gates decide if the particular build that you've just integration tested, does this build deserve to go to the next stage? This decision making is performed by the gate. The integration testing gate will decide whether the integration testing stage yields sufficient and good enough results for this particular build to move to the acceptance testing stage. If the build does well in the acceptance testing stage also, then the acceptance testing gate will permit this build to move to the user acceptance testing stage, right? So these gates are there to see if one particular build deserves to go to the next stage. And now there will be an authority at each gate who will decide whether the build deserves to go to the next stage. Right? When I say authority, this authority could be a human being or it could be an automated script. For example, you know that automated acceptance, we may have automated our deployment pipeline. In that case, the integration test results may be verified by a computer system, and this system will ask the continuous integration system to move your build to the next stage, which is acceptance testing stage. Again, user acceptance testing could be user acceptance testing is done by the customer, and so that gate could be managed by a human being, because he is the person who decides whether he's done the tests, and then he says whether the software should go to the next stage. So manual tests are oftentimes the authorities after the manual tests are usually human beings, and the authorities after each automated test is generally an automated authority. Sometimes it could be manual also, right? So these stages, these gates and authorities, we need to decide upon them, and then once we've decided upon them and also the flow of bills, we can finally say that we've created a proper model for our deployment pipeline. Okay, so finally we've reached promoting builds and configurations, right? Uh, you may have understood by now what promotion means, right? Uh, in the last slide, we saw that there could be one stage, and from the stage, a, a build is tested, right? You take a build, you bring it to the stage, the build is tested, and if the quality is good enough, it moves to the next stage. There will be a gate in between, and there will be an authority there who will decide whether this software deserves to move to the next stage. This process of sending one build to the next stage is what you call promotion, right? A build is being promoted from one stage to the next stage. A build will pass through, or rather it will get promoted through each of these stages, and ultimately it will be promoted into production, right? It will be promoted into production, right? Now, when you do promote a build, do you promote every aspect of this build, or do you promote only certain aspects of this build? Generally speaking, you would promote, if one particular build, if it is doing well, then you would promote all of the executables. You will not hold back any of the executables, because the executables have been tested really well. However, you will never promote the test doubles that are associated with this particular build of yours, right? You don't want to promote the test doubles into production. We discussed this earlier. We don't want test doubles in production. We should replace these test doubles with the actual libraries or whatever. We should have configurations that can do that for us, right? We should have the right configurations that can get the actual libraries, the actual objects, instead of test doubles. So we should never promote test doubles. We can blindly promote our executables, but we never promote our test doubles. And so we should promote only those configurations that help us achieve this. So you promote all the, I say this again, you promote all of the builds, right? And you promote the correct configurations as well, and then you do not promote any of the test doubles. So how can we ensure that we don't promote these test doubles? It's quite simple. A simple approach that is often used is smoke testing your application. You see, we created these test doubles, so we know how these test doubles are going to behave. So what we can do is we can create certain smoke tests, which can detect the presence of these test doubles, and if these test doubles are there, we can get rid of them and release and then promote the application without these test doubles, right? Also, there are certain behavior driven development tools that inherently support selective promotion, right? This is, you can call this selective promotion, because we're not promoting everything. We're selectively promoting good configurations and the build. We're not promoting unnecessary things, right? So there are certain behavior driven development tools. You can go online and then check it out yourself, uh, and see how these tools achieve selective promotion, right? It's beyond the scope of this syllabus to discuss in detail about behavior-driven development tools, right? Before your product finally reaches the market, or before it is deployed into production, there is one final round of testing that you might want to do, and that is performed in staging. And in staging, what you do is you deploy your application into an environment that is an exact replica of production. It's an exact replica of your production, right? Why do you do this? The reasons are quite straightforward. One, just to see if my deployment would happen as planned in production as well. I mean, so far I've been testing it not on production, but on systems that we have in our company. It is not on production. It may have been close to production, but it was not exactly as production. So now you're finally deploying it into a system that is an exact replica of your production, and so you have a better idea of how deployment would happen. The next thing that you should consider, or the next kind of test that you should do, uh, are testing to see how future upgrades would happen. In case of course, we will be upgrading our software in the future. And when we do provide these upgrades, how will these upgrades happen when the system is in production, right? Uh, right. And the third one is about rollbacks. How do you roll back a system that has already been deployed and it's in production? How do you roll back in case of failure? In case of a failed deployment, how will a rollback happen in production environment? This is not an exhaustive list of things that you would be testing. However, these are mandatory things. You must test these at least. These are mandatory when it comes to testing in staging. Sometimes your company may not have the financial or infrastructural backing to create an exact replica of production for staging. In that case, what you can do is you can reuse your capacity testing environment, right? However, this capacity testing environment should be reused only if it is close to production. If it is an environment that has already been, if you've created a capacity testing environment that is already close to production, then it's fine to reuse this capacity testing environment for staging as well, right? We did say that. I hope you remember that from the 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 chapter on non-functional testing, which is capacity testing. We did say that capacity tests are performed on systems that are as close to production as possible. And so, if we do not have the financial backing, we can use that environment instead of a separate staging environment. Right. There are some aspects that again, what are certain things that you look for in the staging area? When performing tests in the staging area, what are those few things that you should always keep an eye open for? Number one, you must see if your deployment is idempotent. And what does this mean? You must see if your deployment is causing unwanted and unwarranted changes to your production system. Is the production system continuing to work as normal even after installing your application, or is it causing some problems? The same should be checked with upgrading. Is upgrading leaving the system idempotent? Is rollback leaving the system idempotent? Your system should not alter, I mean, sorry, your application should not alter the behavior of your production environment. The deployment should add that particular application that you have created, and that's all it should do. It should not affect the working of other software that might be there in the production system. It must not affect the working of the operating system or any other dependencies that other software may depend on. Right. So deployment must always be idempotent. Right. This is another point. So the next thing that you should ensure is, again, this is something that we've already discussed. The staging environment should be as close to production as possible, and if possible, it should be a replica of production. Right. We've discussed that in detail. Now, we I hope you know that the whole point of this subject has been continuous deployment, continuous delivery, continuous integration. All these things have been core ideals that we have tried to achieve in this subject. And because of that, automation has been a key point of discussion. The we must when deploying again, when deploying too, we must create we must create scripts that can automate configurations as well. And these scripts need not be the best right from the beginning. They could evolve to become better over time as you understand more about your product, your automated configuration process can also get better and better. Fine. And again, right, you don't perform extensive testing in staging. You just perform some smoke tests to see if everything is working, everything is in place, and everything is in order. Right.